Okay, so I'll talk to them. Okay, thank you for being here. So the idea is this is more information. So I'm not gonna get into the details of too much things, but this is one of my areas of expertise is simulation, and I've been using simulation for several things. And later on, this is sort of new for me, emergency management. So that's what I want to do, to use the tools that I know for these problems that are new. So we have. What is the background? So we live in a pretty complex society. So you can see here, these are pictures from the 1918 Spanish flu in Europe that killed a lot of people. I think that more than 30 million. And these are images from the Philippines, the typhoon just a couple of weeks ago. I think that is less than 10,000 people so far, but still some areas of that country are pretty devastated. So the idea is there are extreme situations. Some of them are really suddenly. So you have tornadoes. I think that it was in Illinois, Washington, Illinois. A tornado just swept through a neighborhood, and I think that is just 8 people dead. So sometimes you might have as much as 10 or 15 minutes just to run. Get whatever you can get. Hurricanes, they are a little bit more, I think that you can have now weeks in advance for reacting. And typhoons, that I think that is, at that point is similar to hurricanes, you can have in the order of days to react. So these are one of those extreme situations, and there are some other situations which are pretty much, they evolve slowly. So a pandemic, like the flu pandemic, that picture is from that one, so it's evolve slowly. You have more time to react, but it's a little bit more difficult to contain. Or the AIDS epidemic in different communities. So we can think of those two type of things that you deal in emergency management. So usually, this is sort of how did you approach emergency management? So you have prevention. So you want to basically avoid the situation if possible. Preparation, which is pretty much or preparedness. So in case that it happens, then you can try to mitigate the impact. And then once it has happened, it's basically response and relief, trying to get help to the people that is basically affected by the extreme situation. And later on is recovery, pretty much on getting back to the normal situation or the pre-extreme condition situation. So in general, this is the approach they use for emergency management. And what I want to do is sort of use simulation to help in pretty much all the stages of that process. Here, I think that we can skip this one. Eventually, you already know what is a system. Components and relationships, and a model is an abstraction of that system, and a simulation is when you put that system into a computer program and then you can simulate it and get some results. So for example, let me show you. Okay, what? So this is a simulation of an AIDS. So if you see these blue persons are infected with AIDS, and you have here
you can pull it out.
some things that are basically that you cannot control from your system. So you have, in this case, it doesn't matter if it is a heterosexual or homosexual couple, but then there is a tendency to coupling of 5 out of 10. So 50% of the population want to get into a relationship couple, and the average commitment is 50 weeks, less than a year. So that seems, I checked some statistics, and on average in the United States, a marriage is 3 years. So that's on average. You'll have extremes, and this is the same case. So you can increase here. That's gonna be like about 150, or you can 100. So those two type of things are independent. In your system, when you are modeling this small community, those are things that you get from them, and then it's difficult for you to change this one. But what you want to change when you are doing emergency management, in this case preparation and preparedness, is the average condom use. So you can impact that one by using advertising, by offering free condoms in different places, and also you can affect the average test frequency by getting free testing, or by getting a 1-800 line. So call us if you think that you are infected, we'll help you, and so on. So those are the type of things that you can do in order to be prepared, or in order to respond to a specific emergency. So you can change that one, and you can see the impact of. So for example, if we just run the model as it is, so no condom use and no testing, so pretty much free people having free relationships down there, with some of them infected. So eventually you see, so you can see here the couples, and the red ones are pretty much that now they are positive, and you can see how the level of infection, HIV positive, start increasing. So, and again, every time unit is awake and said, then you can say, now we are going over more than 10 years, and our population infected is increasing. So you can evaluate the effects. So how prepared you are to deal with this level of population being infected with AIDS. What happened? So let's stop this one, and now let's see, okay, the situation is pretty bad. So now let's see, we are gonna put on every single bar in the county or in the area, we'll put free condoms. So you'll have to, at least you'll have the opportunity to use condom use. So let's see, 20% of the population, and then you'll set up an 1-800 line in which you can call if you have doubts, and then they will get you a test for free. So let's see that in that case you'll go a quarter pretty much. In this case, every 4 years you'll test yourself. So let's see what happened with that. So they are you'll still get some infected people, but we'll let them run till 700 weeks, and you should be able to see that the number of people that is infected is a little bit. We run it like all the way till 7. Something like in that area. So if you remember, the other graph was a little bit increasing here. In this case, you get some people, again, it's not everybody is using condom, and not everybody is testing, in this case every 4 years, but so that reduces the number of infected people. So in this case, you can use simulation to somehow evaluate your measures. So what happened? Okay, so if I do this one, free condoms for everybody, if I set up ways for everybody to, or if you want to get tested for free, so then that level of awareness is gonna somehow impact the level of infected people at the end of in this case, your planning horizon. These two here are a little bit more difficult for you. How can you change that the average commitment is less than 2 years? Or that's a different story. So you take those things from the system, but those two here you can modify, and you can use them to get change. So that's one of the applications there. So let me I'll just switch, and here we have another one. Let me see. So the previous one, it was more in the what we call long term. So there are some extreme situation, but it happens slowly, and you can have more time to react and to put policies in place to prevent to be prepared or to basically recover from the extreme situation. But there are some other situations, extreme situations, which are basically sudden. So let's think of this simulation is pretty much you are in a room, let's say a classroom or in a movie theater, and for some reason there is a fire. So let's see what happened. This is kind of an evacuation model. So there is a fire. This is the red thing that is going on. So everybody is scared and everybody wants to leave the room. So there is going to be some sort of just people pushing to get out of the room. And as the fire moves towards the people, there is going to be more panic, more pushing. And we can also model this type of behavior when responding to in this case is short time to react type of extreme events, and we can also use this one to sort of analyze what happened if. So in this case everybody is aware, they know where to go, and eventually I guess some of them are gonna get burned. But you can think, okay, if something like this happen, eventually some people will die. So what we can do? To be prepared, have more exits, emergency exits, to have better labeling and stuff so you can know where to go, to have some sort of a plan. So if you are in this area, go to this exit, or if you are in this area, and you can see those things in these buildings. So pretty much if you are here, use this emergency exit. If you are there, it's better if you use that other exit. If you see here, at the end of the day, we have some people that got born, and so again we can use simulation in order to see prevention measures, to be prepared, and also how to the relief of the after an extreme situation. Okay, so we have some examples there. So the name of the talk is hybrid models. I'm not going to get into the details, but usually when you want to basically cover, let's go back to here, to cover all of this process, prevention, preparation, response, and recovery, usually you'll have to integrate different simulation models. For example, one of the possible projects is with Colorado Springs. So the last couple of summers, they have fires, the Waldo Canyon and the Black Forest Canyon Forest, Black Forest. So pretty much those two areas got fires 2012 and 2013, and now there are a lot of areas without any trees, any vegetation coverage, and a small rain can cause flooding.